Hey, okay, it's time to go over this second page. Actually, it's the third page of this paper. This time they have out the formulas written out. I do not want you to write out the names of these products. Right? I don't want you to do that. Instead, what I want you to do is just write the formulas and then balance the equations. So let's get started right here. Now the first thing you need to do is realize where we're getting these numbers. So we're using our periodic table with the ion charts, and we're going to find out these charge numbers. So we have Ba, and Ba, if you use your table, you find out that Ba is +2. Now, you might have to type this out. That's fine if you're typing it out, or you can write it. Some people that have very gifted at writing on these little track pads, that's great. Either way, I would probably write it. You guys type a lot. That looks great too. So the next thing we have is we have chloride. We find that, and Cl is -1. Now, as you write your formula down, make sure that you crisscross these. So we're going to put a 1 here and a 2 here, and in real life, no one's going to put a 1 there, and I wouldn't normally do that, but I'm just trying to show you what I'm doing right now. Plus sodium sulfate. So sodium is Na, and sulfate is a polyatomic ion. You'll have to use the back of the chart to find your polyatomic ions, and that's sulfate, that's SO4. All right, that's a -2 charge. Sodium is a +1. All right. Now, look what we have here. 2, 1, crisscross, we need a 2 there. Once all your formulas are correct, like we have right here, which I know that's correct, right? Then we're ready to do the second part. And the second part of this is to find out what our products will be. So we'll draw a little arrow here. And our products, because this is a double replacement reaction. I know it's a double replacement reaction because we have 2 couples and they're going to switch partners. So what you're going to do is you're going to take the Ba. Now, you could start with the Na if you wanted to. It doesn't really matter, but we'll start with the Ba. You'd start with the Ba. It's +2. And it's going to go now with the other ion, the other anion, which would be sulfate, and it's -2. +2, -2, we don't need any subscripts. Plus Na. Na is +1, and Cl is -1. And notice I did not bring those subscripts across the yield sign. Wait a minute, Mr. Arnold, you brought the sulfate subscripts across the yield sign? Yes, because it's a polyatomic ion. They're in parentheses, I can take them across. If they're not, if it's just an ion that's sitting here like this, or just a 2 outside here, telling me how many atoms I have, I'm not taking those across the yield sign, right? I'm going to get those charges from I'm going to get those subscripts from the charges, right? That's where we get all of our subscripts. At this point now, you're ready to balance, and we'll look to see what we have. I see that I have 2 Nas on the left, and I also see that I have 1 on the right. So I need to put a 2 in front of that, and that gives me 2 Nas. Now I have 2 Cls on the right, and by golly, I already have 2 Cls. So that's done. All right? So that's what we're going to do in these. Now, what I'm going to do for you is I'm going to start you off, just to save you some time. And we're going to start off, and this will be Fe, that Fe2, that means it's Fe +2. Sulfite is S -2. The formula is already correct. Plus hydrochloric acid is H. H is +1. Cl is -1. There you go. That's a double replacement reaction. The formulas I have on there are correct. You just finish that up, write the formulas, balance. This next one is Mg plus nitric acid, and nitric acid is HNO3. H is +1, NO3 is -1. Mg is +2 because you're going to need that on the other side, right? All right. Now, that is one thing and then a couple. So that's going to be single replacement, right? We're going to be cutting in there. And then you're going to have to change those over, write the formulas, and then balance. Now, be careful because this right here, this H is going to be separated by itself. It's going to be diatomic. So it's going to be H2 when you get done. It has to be because it's diatomic. And we talked about diatomics like 3 times now in chapters. This is why, because this is when people forget to do them. All right, now, this time we have sodium, Na, and plus water. Now, water doesn't react H2O. It does sometimes, but in this case it doesn't, right? And you'll learn later in this chapter when it does and when it doesn't. But in this case, it's going to react HOH, right? Still water, but it doesn't. The sodium doesn't take away both of the hydrogens. It just takes one of them away, and it forms sodium hydroxide and H2. And again, be careful. Single replacement reaction, that H is going to be by itself. Let's put those charges up here for everybody. And so that H is going to be by itself, so it's going to end up being H2 out here, right? Diatomic. And that's a single replacement. In this case, we have silver, which is Ag plus 1, and we have sulfur, which is S minus 2. All right? Now, this is a synthesis. It should be easy for you to put them together. Make sure you write the formula before you balance. We have sodium, Na plus 1, and iodide, which is minus 1. Formula's fine. Plus bromine, Br2. Bromine is one of those diatomics, so I had to put a 2 there. Now, that diatomic is only important or only happens when it's by itself. So here, Br is Br2. When we go through this reaction, it looks like Mr. Arnold's taking us through this reaction right now. NaBr plus 1 minus 1. That's not going to be a 2 on this side. It's going to be a subscript 1 because those subscripts are coming from the charges. Plus I. Now, if you remember your diatomics, and I just highlighted them on the board today for your class, but iodine is also diatomic, so you need your 2 there. So you have to have this formula correct like this before you can balance it. I am going to let you balance this, though, so you have to put the coefficients and the large numbers in, okay? I'm going to leave it as that. All right, we have zinc. Zinc is plus 2, plus Pb plus 2, because it's lead 2, and then acetate, C2H3O2, and that has a minus 1 charge. So we're going to need a 2 subscript outside of that. Right? Draw an arrow. Boop. You have to finish that one up. That is, of course, a single and a couple. That's a single replacement reaction. Did I say which one this one? This one also was an SR. Okay. And last but not least, we have lead acetate. Hey, it's the same exact thing, right? Lead acetate. This time it's plus hydrogen sulfide. So H is plus 1, sulfide is minus 2. We need a 2 right there. There's our line. Look at that double replacement reaction. And so you're going to switch couples. All right. I hope that's enough information. I'm trying to go as fast as possible. And oops, let me see what I covered up there. Yeah, I'm trying to go as fast as possible. Hopefully you had time to write down the things you need. You can, of course, pause it as you go through if you haven't. And I hope you finish this up and you'll be caught up with the rest of the classes. All right. Thank you very much. And I am